Hello and welcome students. We are starting with a lecture on relations. Earlier to this, I have completed the lecture on sets. So the sequence is first you learn about sets and then you go ahead with the relations. So we will start with relations and after, see it is, we do sets and after sets we do relation and after relation we go for functions. So this is the sequence that we normally follow. So we have done sets. Now we are going for relations. And after relations, we will come to functions. So let us begin with relations. What is a relation? To understand this, we will first have to learn the idea of Cartesian product of two sets. So first we need to know, we will first have to understand Cartesian product Cartesian product of two sets. We have to first understand Cartesian product of two sets. Okay, so see here, let us have two non-empty sets. So I write here A comma B comma C, which is a non-empty set. A is A comma B comma C. It's a non-empty set, and n of A is 3. What is meaning of n of A? N of A is the number of elements in set A, which is equal to 3. Then I write another set B, and set B is, say I have here 1, 2, 3, 4. And here I have got 4 elements, so I write n of B as 4. Now I define the Cartesian product. See, Cartesian product of A and B, I will go for. So Cartesian product of A and B. See, Cartesian product of set A and set B can be obtained in two ways. It can be obtained in two ways. See, the first one is A cross B. This is Cartesian product of A and B, where the elements of A will be the first element. Okay, the elements of A will be the first and elements of B will come second. It is known as A cross B. It is read as A cross B. The another type of Cartesian product on A and B will be B cross A, where the elements of B will come first and A will come second. This is B cross A. Okay. So right now I will go for A cross B. I'm going for Cartesian product of A cross B. So here when I write A cross B, it will be as follows. See, I first write a set. Remember that A cross B is also a set. A is a set, B is also a set, A cross B is also a set. But then A cross B is set of ordered pairs. A cross B is a set of ordered pairs. It is set of ordered pairs. Okay. Now what does mean? What is meaning of ordered pairs? You will know it. See, let me first write the first element of A cross B. It will be A comma 1. See, this is one ordered pair. A comma 1, A comma 2, A comma 3, A comma 4. Then I will write B comma 1, B comma 2, B comma 3, B comma 4. Then I write C comma 1, C comma 2, C comma 1, C comma 2, C comma 3, and C comma 4. So see, we have got the set A cross B. And what is it? It is Cartesian product of set A and B, where the elements of A are the first component in the ordered pair. You can check. This is ordered pair. So see, these are ordered pairs. A1, A2, A3. These are ordered pairs. You can check. You have pairs inside the set. You have a pair. See, two elements, two components. Okay, you have two components separated by a comma in between. Separated by a comma in between. Now, before comma, you have the first component, and after comma, the second component. Now, what you notice that first component is always from set A, and the second component is from set B. Why? Because it is A cross B. So this is A cross B. How will you write A cross B now? In set builder form, you will write A cross B as it is set of A cross B is set of X comma Y such that X belongs to A and Y belongs to B. See, this is the definition of A cross B. What you wrote? You wrote A cross B in set builder form. A cross B, set A cross B, which is the Cartesian product of A and B. Set A cross B is a set of ordered pair X comma Y. Ordered pair X comma Y. Very good. But then you will have to give the property of X and Y. It is set of X comma Y such that X, which is the first component, it is always from set A. It's always from set A, and the second component is from set B. This is A cross B, X comma Y. I shall now be writing B cross A. As I told you, you can have A cross B as well as B cross A. So let us write now let us now write here B cross A. So the set B cross A is, once again, it is a set of ordered pairs, but this will have the first component of B. So you will have 1A, you will have 1A, 1B, 1C, 1, that's it, 1C, 1A, 1B, 1C. Then you will have 2A, 2B, 2C, you will have 3A, 3B, 3C, 4A, 4B, and 4C. This is B cross A. And if you want to write B cross A in set builder form, you will write it as set of X comma Y such that X belongs to B, that is the first component belongs to B, and the second component Y belongs to A. This is set of X comma Y, where X from B and Y from A. This is B cross A. This is B cross A. So there are two types of Cartesian product set from two sets A and B. This is Cartesian product of sets A and B. It is Cartesian product of sets A and B. Now, if you want to know how many elements are there in A cross B or B cross A, you can check. Count the number of elements in A cross B. Now see, the number of elements in A are 3. 1, 2, 3. There are 3 elements in A and there are 4 elements in B. Now let's go for the number of elements in A cross B. So here you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. See, in A cross B, the number of elements in A cross B is 12. So here I write here n of A cross B, n of A cross B equals to 12. Now it is noticed that the number of elements in A cross B will be equal to number of elements in A multiplied by number of elements. Okay, I'm extremely sorry, students. This is not small a, it is capital A. Okay, I made a mistake here. It is the set A in which, okay, So number of elements in A. This is not small a, it is capital A. And so as this is also capital A. Yeah, student. It is noticed that number of elements in A cross B is equal to number of elements of set A multiplied with number of elements of set B. You can check. In set A, you have 3 elements. In set B, you have 4 elements. What is n of A into n of B? It is 12. So as the number of elements in A cross B, that is also 12. That is also 12. So this is the formula for number of elements in A cross B. You can check here the number of elements in B cross A. The number of elements in B cross A also you have is 12. You can count it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here also you have 12 elements. Once again, I can say that n of A cross, here also I have n of B cross A equals to n of same thing, n of B into n of A. The number of elements in B cross A will be equal to the number of elements in B into number of elements in A. That is 4 into 3, that is 12. So I hope you followed this part. Now let's have a question here. I'm given if x minus 1 y plus 4 equals to 1 comma 2. If I'm given x minus 1 y plus 4 equals to 1 comma 2. See students, there is an ordered pair here and there is an ordered pair here. What I have to do is I have to get the value of x and y. Now when the two ordered pairs are equal, it simply means that first component of both the ordered pairs are equal and the second components are equal to each other. So here the first component is x minus 1 and here it is 1. So I would write therefore x minus 1 equals to 1. This implies x equals to 2 and y plus 4 equals to 2. Y plus 4 is 2, so this implies y equals to negative 2. So I got x value. Now similarly, in the second question, you will notice that there are two ordered pairs in the second question also. I'm given x plus 1 by 3, comma, y by 3 minus 1 on the left hand side, which is equal to, this ordered pair is equal to half, comma, 3 by 2, 3 upon 2. We have to find the value of x and y. So it is if this equals to this, find the values of x and y. Find the values of x and y. X and y. Okay. So what you have? So here you have x plus 1 by 3 equals to 1 by 2. This implies x equals to 1 by 2 minus 1 by 3. So what's the LCM? The LCM is 6 here. You get 3 minus 2. So you got x equals to 1 over 6. And secondly, you will find the y value. So here you have, see here, y upon 3 minus 1 equals to 3 by 2. So y upon 3 is 3 by 2 plus 1. So y upon 3 is 3 by 2 plus 1. So you got y upon 3 as 5 by 2. So this gives you y equals to 15 by 2. This gives you y equals to 15 by 2. So you got x as 1 by 6 and you got y as 15 by 2. So these are the two values of x and y that you got. I hope you followed it. Here we have another question. In this question, we are given two sets A and B. We are given two sets A and B. And set A is ABC, which I have written for you. And set B is x comma y. Set B is x comma y. We have to find A cross B. We have to find B cross A. We have to find A cross A and B cross B. Now, what is meaning of A cross B? It's the Cartesian product set of A and B. See, it is the Cartesian product set of A and B, where the first component, you know, a Cartesian product set is set of ordered pairs. So the first component is A from the set A. This is Cartesian product set of A and B, where the first component is from set B. This is the Cartesian product set of A with A. It's the Cartesian product set of A with itself. See, A cross A is the Cartesian product set of A with itself. Okay, what does it mean? It means that here in this, the first component is from set A and the second component is also from set A. So if you define A cross A in set builder form, you will call it as set of x comma y such that x belongs to A and y belongs to A. Okay, such a set is also termed as A cross A is also termed as A square. Sometimes we also write A cross A as A square. Okay, so and so as B cross B. Okay, B cross B is also Cartesian product set of set B with itself. So I hope you can solve this on your own. It's a very easy. It's a very. Here I have written two more questions for you. See, question number 4. This 4 you all can solve on your own. See, question number 4 is as you had question number 3, so as question number 4. In this, they give us a set P. They give us a set P and a set Q. Okay, set P has 3 elements, 1, 2, 3. Q has 1 element, a single element. This is 14. Now they want us to get the sets P cross Q and Q cross P. Very simple, you can do it. Let's come to question number 5. Question number 5 is they give us 2 sets A and B. In question number 5, we are given 2 sets A and B. I'm sorry, we are given 3 sets A, B, and C. And in set A, I've got the elements 1, 2, 3, 4. In set B, I have the elements 4, 5, 6. In set C, we have 5 and 6. Now there are two statements they give us, and they want us to verify these statements. The first statement that I have to verify is A cross B intersection C. You understand A is a set. You understand A is a set. You understand B intersection C is also a set. B intersection C is also a set. It is the intersection of 2 sets B and C. So we have 2 sets, and now it is on the left hand side, we are given the Cartesian product of set A with set B intersection C. And we need to verify this rule. We need to verify this statement. What it is, A cross B intersection C will be A cross B, see here, A cross B, see here, then A cross C, see here, and since you had intersection, so intersection in between. It's like distributing cross over intersection. It's like distributing cross over intersection. You are distributing. How you distribute product over sum or difference? When you are multiplying a number. You remember when you multiply, suppose you have 5 multiplied 2, 5 multiplied 2, A minus B, where 5 is a number, A and B are also numbers. See, here we don't have sets, we have real numbers. Okay, so 5, how do you multiply? You write 5 into A minus 5 into B. So how you distribute this 5 over the difference? Same way, you are distributing A over, you are distributing cross over intersection. Okay, so we have to verify this. Same here also. Now A cross is verified. It is distributed over union. So A cross B union A cross C, you can see on the right hand side. So I'll do one, and one of these you will solve. Okay, how do we verify this? Let's do it. So first I will find out B intersection C and B union C. Let us find out these two sets. So I'll find out B intersection C. The set B intersection C, you all know what is B intersection C. B intersection C is a set of elements which are in B and C both. Okay, B intersection C will have those elements which are in set B and in set C. They are in both. They are common in both. Okay. So what do you have? Do you have 4 in C? No. Do you have 5? Yes. So you will write 5 and you will also write 6. See, 5 and 6 are there in both. So this is B intersection C. I write this as 1. Then I go for B union C. See, I go for B union C. Now what do you write in set B union C? See, B union C is a set of elements. It is the set of elements which are in B or in C. Those elements which are in B or in C. So you will first write all the elements of B, 4, 5, 6. Okay, because they are in B, so you wrote. And now you will write whatever elements you have in C. So you have 5 and 6, but then those 5 and 6 you have already included. So you will close the bracket. So this is set B union C. Now I will go for the left hand side of 1. Okay, let me go for left hand side of 1. So what do I have left hand side of 1? See, it is A cross B intersection C. I have to find the cross product of, I have to find the Cartesian product of, let us not call it as cross product, call it Cartesian product, because cross product we have in vectors. Okay, we have that in vectors. So what I have to do, I have to get the Cartesian product of set A with set B intersection C. So see, here you have set A and here you have B intersection C. Let's get the Cartesian product. Remember students, that first component will be from A. So here you have 1, 5, you will have 1, 5, 1, 6, then 2, 5, 2, 6, you will have 3, 5, 3, 6, you will have 4, 5, and 4, 6. See, this is A cross B intersection C. A cross B intersection C. Then you will have A cross B intersection C. You got this. You write this as 2. Sorry, 3. Write this as 3. Now go for A cross B and A cross C. Go for A cross B and A cross C. So A cross B. Get the Cartesian product of A with B. You will get A cross B. What is A cross B? Very simple. A cross B will be 1, 4, 1, 5, 1, 6, 2, 4, 2, 5, 2, 6, 3, 4, 3, 5, 3, 6, 3, 4, 3, 5, 3, 6, 4, 4, 4, 5, and 4, 6. This is A cross B. See, I got A cross B. I've already found this. I'm working on the first one. I'm working on verifying the first one. So I first found the LHS of first one. I found the LHS of first one. Now, then I found the A cross B. It's time I found A cross C. Let me find now A cross C. So here A cross C is, you write A cross C. So 1, 5, 1, 5, 1, 6, 2, 5, 2, 6, 3, 5, 3, 6, 4, 5, 4, 6. This is A cross C. Now what you do is you have to now find the RHS. What is RHS? A cross B intersection A cross C. RHS is the intersection of these two sets. What is RHS? RHS is intersection of these two sets. Okay. So here I have A cross B intersection A cross C. Let's find out. Now, what's the meaning of intersection of A cross B and A cross C? What's the meaning of these two? The meaning is whatever elements you have in this and this, both. Okay, you have to get the intersection of these two sets. Try understanding. This is A cross C, and here you have A cross B. Those elements which are in this set and in this set, both the sets, you will write them as the intersection of A cross B and A cross C. Remember that this time the elements are ordered pairs. The elements are ordered pairs. So see, this is one element, two element, three element. The elements are ordered pairs. Try understanding this. Okay. So here I have, see, 1, 4. Do I have 1, 4 here? No. 1, 5. Yes. So right here, 1, 5. Then 1, 6. Yes. See, 1, 6 is in A cross B. It's also in A cross C. So write 1, 5 we wrote, and 1, 6. Right? 1, 6. Then do I have 2, 4? No. 2, 5. Yes. So 2, 5 I have here and here. 2, 6 I have here and here. Yes. 2, 3, 4 is not there. 3, 5 I have. Then 4, 4 is not there. 4, 5, 4, 6 I have. So here I'll have 1, 6. Then I have 2, 5, 2, 6. I have 3, 5, 3, 6, 3, 6. Then I have 4, 5, and 4, 6. So this is it. Okay. I got here A cross B intersection A cross C. I got here A cross B intersection A cross C. So look at, I write this as number 4. This is number 4. Now look at the equation 3. Look at the equation 3 and equation 4. Look at equation 3 and 4, and you will notice that the RHS are same. The RHS are same. So what you have now, you have A cross B intersection C is same as A cross B intersection A cross C. This is what was to be proved, and you verified it. Okay, this was to be verified, and see, you have verified the first one. So you can write here from 3 and 4. So the answer that you can now write is, you can write here from 3 and 4. Therefore, from 3 and 4, 3 and 4, we verify that A cross B intersection C is equal to A cross B intersection A cross, I'm sorry, A cross B intersection A cross C. A cross B intersection A cross. I hope you followed it.